This video, we're going to continue our look into rational functions, but in this case, we're going to learn that there's also such a thing as a slant asymptote. While there may be vertical and horizontal, there may also be slant asymptotes. Again, an asymptote is a line that the graph is approaching but never going to touch. So what is a slant asymptote? It is an asymptote that is not vertical, not horizontal, but it's still an asymptote. It will occur, we will have a slant asymptote if the degree of the numerator is exactly 1 degree higher than that of the denominator. So in general, if your rational function is p of x over q of x, and p and q have no common factors, and the degree of p is exactly 1 greater than the degree of q, then the slant asymptote can be found by dividing q of x into p of x. Because the easiest way to learn is by example, let's find the slant asymptote of f. But I also want to tell you, because I will use the word oblique frequently, though your textbook uses slant, I use oblique, and I have no idea what you may encounter in later classes. So be familiar with both terms. But find the slant asymptote of this function. First, let me remind you that there will be a vertical asymptote, because that denominator, I can't cancel it out, so x equals 1 will be a vertical asymptote. It will have a slant, because the numerator is degree 2, the denominator is degree 1, and 2 is exactly 1 more than 1. So I'm going to divide. I want to use synthetic division because I think it's faster. And that's 1x squared plus 0x plus 0. And x minus 1 goes in the box. So bring down my 1. 1 times 1 is 1, add. 1 times 1 is 1, add. Ignore the remainder. This would be the binomial x plus 1. So y equals x plus 1 will be my oblique asymptote. And to show you what this graph looks like, notice I have a vertical asymptote at x equals 1. I have an oblique or slant asymptote at y equals x plus 1. And my graph is right here in the blue, squeezed in between those asymptotes.